Okay, so let's go see if we can go finish up 9.2. So we're going to start on page 572 where it says putting it all together. One sample z-test for p. Okay, so we're going to actually do it in a structured way. We're going to put it all together, right? So just like the ways that we did before, we're going to state, plan, do, and conclude, right? So in the state, you're going to state that we are doing a one prop z test, okay? Because this is a z test. It's a normal distribution, right? We're doing a standardized normal distribution, right? And it's a proportion, so it's a one prop z test. We're going to do a one prop z test, okay? And we're going to state what? We're going to state the actual ho and the ha and the significance levels, okay? Plan is where we'll go ahead and check the three conditions that need to be met, which are the random sample, less than 10% sampling, and the large counts. The do is actually where we calculate the p, and we will make a comparison with the p and the alpha. And conclude is where we will hopefully find that it looks this way, and we can say that we reject the ho, and we have significant evidence for, or convincing evidence for the ha, right? Okay, so that's what we would hopefully find in the conclusion, right? But we'll have to see, right? See how that goes, right? Okay, so if you look at page 573 on the bottom, there's a green box, and I'm talking about a one sample z test for proportion. Okay, so if you look there are three different alternative or ha's here, right? One is either it's greater than the p, or one is less than the p, and one is where it is not equal to the p naught, okay? So when it's not equal to the p naught, that means that what? You can actually be on either sides, right? It's a two-sided thing, whereas the other two are one-sided. So the one on the left-hand side or the one in the middle are both one-sided versus the one on the very right is two-sided. And we'll talk about that later, okay, how that works. Okay? So let's see if we can do an example. So let's go back to our potato chip manufacturer, right? Let's go back to our potato chip manufacturer. And it says here that if the producer finds convincing evidence that more than 8% of the potatoes in a shipment have blemishes, the truck will be sent away. Otherwise, the entire truckload will be used to make potato chips. The potato chip producer has just received a truckload of potatoes from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection that 47% of the potatoes have blemishes. Is there convincing evidence at the alpha at 10% level that more than 8% of the potatoes in the shipment have blemishes? Okay, so let's find out. So the ho is what? The ho is that P is equal to 8%, right? P is equal to 8%, right? The ha is, P is, what we're trying to prove. We're trying to prove that there's more than that, right? We're trying to prove this, right? That there's more than 8%. And we have some evidence, right? Because we did 47 out of 500 is that, and that is what, 9.4%? 9.4%. So it's greater than the 8%, right? So we have some evidence. The question is this enough evidence, okay? So that's that. So that was the state. Okay, so this would have been the state. And we'll do the plan. The plan is, yes, it was a random sample. And we tested 500 out of a truckload of them. So we're assuming that it is less than 10% of the entire potatoes. And we have to do NP, right? So what do we find here? So we have where are we at? So we have 8%, right? 8%. So we're going to go 500 times 8%. And that is going to be equal to 40 greater than 10. Then we're going to have 500 times 0.92, 460, 10%, right? So all the three conditions are met. So now we'll do the calculate. We'll do the calculate to find the actual p-value. So calculate the p-value is what? P-value is, this was our actual thing, so it's going to be 0.094 minus the 0.08. And then we're going to go, what? Right here, right? So we're going to have 0.08 times 0.92 over 500. Okay. And if we do that, we get 1.15. This is 1.15. So if we look up 1.15 on our table A, we're going to find that the p-value is 0.125. So the p-value was 0.1251. 1251. Okay, so the p-value is what? 12.51%. Okay, so we're going to have to compare the p-value with the alpha, and our alpha here was 10%. Alpha was 10%. So is the p-value is actually larger than the alpha, which means that what? So our conclusion is that we fail to reject the whole. We do not have significant or convincing evidence that the probability, proportion of potatoes with blemishes are more than 8%. Okay, so that would be our conclusion. All right. Okay, so on page 575, it all talks about what happens when the data does not support the alternative. And so we're trying to prove this, and let's say that we did our sample, but our sample came up with 7.5%. So we are on the wrong side of this to begin with. Okay, then it's not, there's no way, you don't even have to do the testing. It's not going to work out. Okay, your p is always going to be greater than alpha. Okay, is what they're saying. All right, so remember that. Go to page 576. 576, it walks in the technology corner, it walks you through how to use your TI-84 to do a 1-prop-Z test. Okay, so if you go there, you go to on page 576, says you go stat, then tests, then you press the 1-prop-Z test. It's going to ask you to put in the P0, which is the probability and proportion of this guy right here, the actual whole, okay? And then it's going to ask you to put in the number of that you got. You had 47 out of the 500, so it's asking you to put the 47 and then the 500 in. Okay, so that's the X and the N. And notice that the prop, it has whether it's not equal to P0, greater than, or less than P0, okay? So it needs to know which side, are you doing a one-sided or a two-sided? And if it's a one-sided, it's going to be greater or less than, okay? And then you calculate it, and it should give you the if you look on page 577, it says that this gives you the Z value, and it gives you the P value, and from there, you have to compare it to the alpha, and then do the conclusions, okay? Okay, so it's basically give you, when you do the 1-prop-Z test, it spits out the p-value for you. Okay, so it doesn't have to, you don't have to go through all this to finding the p-value. Okay, so that's the advantage of doing that. So let's see if we can do a two-sided test here. Okay, so let's say that we're going to do page 577, the non-smokers. Okay, let's see if we can do that. The non-smokers. So what do we have here? We have, according to the CDC website, 68% of high school students have never smoked cigarettes. Okay, 68%. Yanholm, who wonders whether this national results holds true in her large urban high school. For her AP Stats class project, she surveyed a random sample of 150 students from her school. She gets responses from all 150, and 90 say they have never smoked a cigarette. Is there convincing evidence that is not wholly true? So let's find out. So our P is going to be what? P is going to be the 68% here, right? P is going to be the 68%. Okay, so we're saying true or not true. It doesn't really, she doesn't state whether they are looking for greater or less than. So the high in this case is going to be not equal to, okay? Meaning it's going to be a double-sided, okay? And the alpha, does it say that? I don't remember reading an alpha here. So there's no alpha, meaning that what? The alpha is going to be 5%. 5%, and we had 90 out of 150, right? 90 out of 150. 90 out of 150. Okay, so it's a random sample. It's a large urban school, so this is good. And if we do this, what do we get? We're going to get 150 times 0.68, 150 times 0.32, 1 minus p, right? And these are both going to be greater than or equal to 10. And so we'll do the calculations to find the p-value, right? So we're going to get what? We're going to get... This guy here is what? This guy here is 5/3. So this is going to be 60%, so 0.60, 0.60 minus the 0.68. 0.68 times 0.32 over our sample size of 150. And if we do that, we're going to get negative 2.1. Negative 2.1. And if we put that in there, well, if we go to table A, what we're going to find that our p-value for A, one side is going to be 0.0179. So we're going to get so our p-value is going to be, in other words, so this would be 0.68, 0.60. This guy here is going to be 1.79%. 1.79%, right? So we're looking at E not equal to, right? So it actually could be either on this side too. So it's a two-sided thing. So I have to take the 1.79 and multiply it by 2 because I have both of them, right? So the p-value is going to be 1.79 times 2. Okay, and if we do that, we get what? 3.57%, 3.57%. So our p-value is, so this is fairly important here. This is fairly important that you have to multiply it by 2. You have to multiply it by 2. So 1.79 times 2 is that. Okay, now we compare that to the alpha, which is 5. P-value is less than alpha. So our conclusion is what? Our conclusion is that we reject the whole. We have convincing evidence that the probability of true proportion of people, high school students smoking is not 68%. Okay? And so that's that. And we'll finish up 9.2 with this.